Today, the price of copper is subject to strong fluctuations caused by speculation. An alternative? The nodules in the deep sea. What do they contain and what's the cost? Deep sea research explains how economics and ecology can be compatible.
If we're to mine the deep sea, it needs to be done as responsibly as possible. And to do that, we need to conduct environmental research. Because if we don't understand it fully, we can't mine in an ecologically sound way. And what's more, scientists are more suited to the task than those who want to mine the nodules, because their primary goal is to mine, even if they say that they'll take a little care of the environment. Our primary interest is to understand the environment.
Interesse ist, die Umwelt zu verstehen.
Pioneering work is absolutely necessary in the case of the deep sea, as the ecosystem here remains almost completely unknown to us. Researchers first want to find out about the life that inhabits the fields of manganese nodules on the expedition. The metal and sand nodules have already been lying here for millions of years. They're utilizing various methods to go about this. This claw cuts out pieces of the seabed, takes it up to researchers on the ship from a depth of 4 kilometers. There are manganese nodules in all of the oceans, but only in the Pacific, in the so-called manganese nodule belt, do they reach such a high density that industrial mining really makes sense. "150 years ago, the expedition, the Challenger, provided an insight into this mysterious world. A good 20 years later, the first German deep-sea expedition followed, with Valdivia. In 1898, the German Empire wanted to no longer lag behind Great Britain. For months, their researchers sailed through the Arctic. Back then, the conventional thought was still prevalent that the deep seabed was a lifeless desert. The German scientists tried to research the seabed with trawl nets. As the first nets were lifted, there was great surprise. It was clear that countless animals were living on the seabed, and almost all of them were unknown to the researchers. Up on deck, they examined and categorized the foreign organisms. They brought home countless specimens and detailed illustrations with them. Even today, scientists have not yet managed to finish examining all of the containers of mysterious creatures. Unlike their colleagues in past centuries, modern sea researchers are now able to observe animals on the ocean floor in their element. They've known for a long time that the deep sea follows its own rules. The clocks of the deep sea tick to their own rhythm. The animals here grow slowly and become very old, many only reaching sexual maturity at 30 or 50 years old. The manganese nodule evolves in this mysterious world. It always needs a core. Many modules contain shark teeth. Metals dissolved in the water slowly accumulate around the core, a process that takes millions of years until finally a fist-sized nodule has formed. But how does this slow universe react to attacks from the outside? Sea biologists asked this question in the 1980s. Even then, intensive debate surrounded manganese nodule mining. In order to imitate a disruption similar to that of mining, they lowered a plowing harrow down into the deep and pulled it across the seabed, 78 times in total. 7 years later, in 1996, they found the same spot in order to check the test area. The marks left were still visible. Today, a good quarter of a century after the original experiment, they're traveling back there again. More than anything, by now it has become much clearer how little we know about the deep seabed. Matthias Heckel accompanied the party in 1996 as a young doctoral student.
The deep sea covers 70% of the surface of our Earth, and we have, up until now, really only made point measurements. 10, 15, 20 years ago, we thought everything in the deep sea was pretty much the same, even in an area such as where we are right now. Now we're in an area of 2 sea miles in diameter, so about 3.5 or 4 kilometers large. And normally, we always thought that on the scale of several tens of kilometers, everything is homogeneous and the same. And now we're seeing that even here, in these 3 or 4 kilometers, the variability is relatively large.
The claw will show how much of the variety is still present. If it has brought a piece of the seabed as planned, it will deliver valuable findings. Every single specimen taken in the deep sea is a small piece of a mosaic that can generate more knowledge. A lucky turn. It's a good haul. The sea biologists carefully retrieve the sediment and nodules. Every single sample will be examined immediately on deck and later analyzed further on land. Because such an expedition guzzles a lot of money, work is continuously done on the Sonne around the clock. Researchers from all over the world share the layers out and use every single minute. Slowly, the sediment releases its treasure. The manganese nodules are measured and weighed. From an economical perspective, it's true to say, the bigger, the more valuable. Large nodules are easier to mine. They required millions of years to grow to that size. The sea has always fascinated mankind. Endless expanse, awe-inspiring waves, a space for yearning, around which countless myths are based, in which anything seems possible. The elemental power of the ocean instills fear in us. Yet at the same time, we've always wanted to conquer the oceans. They also promise us great gains. Even the earliest businessmen didn't dare venture into the dangerous oceans to make a profit. Later, with better ships, the exploitation of the ocean progressed more and more. In its early days, whaling was lethally dangerous for sailors, but the work was good money. Valuable whale fat was required for candles, cosmetics, and many other uses. The extinction of the whale was only prevented by the realization that crude oil could be used as a replacement for whale fat. Nowadays, fish stocks are in similar danger to the whale. Not a single fish can escape the trawl nets that are now dragged across the seabed. Many species are threatened by extinction. Although the fish stocks in the deep sea are being ruthlessly exploited, the seabed remains unknown to us. It's true to this day. We know more about the surface of the moon than we do about the deep seabed. Every impression of the seabed is unique. These researchers are the first to be able to see the deep seabed in the same place that the earlier experiments happened 19 years ago. In almost 2 decades, technology has moved forward exponentially. Today, much clearer images of this mysterious world are possible.
When we take a TV camera across the seabed and we see the image live, we're the first in the history of humanity to have seen this part of the Earth. Time and again. Even now, I'm getting goosebumps. New every time. For me, that's spectacular.
Extracting manganese nodules once seemed within reach, at a time that was characterized by a similarly pioneering spirit. In the 1960s and 70s, people believed nothing was impossible. Man had succeeded in reaching the moon and even standing on its surface.
There you go.
The Mariana Trench, probably the deepest part of the sea, had been navigated by the Frenchman Jean Picard with his submarine. What else was lying out of our reach? People dreamed of houses on the seabed, where they could live just as naturally as on land. But this optimistic time was also one of the most dangerous in history, the time of the Cold War between East and West. The Soviet Union and the USA stood irreconcilably against each other and left no stone unturned in their spying efforts. When a Russian submarine sank in the middle of the Pacific, the USA used manganese nodules as a cover-up story. A ship built by the billionaire Howard Hughes was apparently going to research how manganese nodules could best be extracted. In reality, the American CIA wanted to salvage the submarine. It was the most expensive CIA venture in history. The international public swallowed the story of the manganese nodule mining. The submarine, however, tore apart while being retrieved. Only parts of it made it to the deck to be analyzed. The hype surrounding the manganese nodules back then was short-lived. Ores were cheap. The mines on land seemed inexhaustible. Today, on the other hand, extraction from the seabed seems inevitable. All over the world, research is being carried out looking into how the raw materials can best be extracted from the nodules.